let me explain about the BGP. So today I'm gonna teach you about the BGP. So BGP full form is Border Gateway Routing Protocol. Border Gateway Gateway Routing Protocol. BGP full form is the Border Gateway Routing Protocol. So let me draw the diagram. So this is the R1. It is connected to the R2 and R2 connected to the R3. So BGP definition is that the BGP sends routing update packet, update packet non-periodically to all OS, to all, not all, BGP sends routing update packet to BGP speakers by unicasting. So what do you mean by the routing protocol? So routing protocol, how does routing protocol? Suppose this is the loopback one, and suppose this is my Facebook, yeah, and its IP address suppose 1.1.1.1/8. So first it will advertise the update packet from R1 router to R2 router, yeah. So in its update packet, suppose this is the update packet, yeah. In the update packet, it is mentioned the matrix suppose 10, yeah. I'll explain you what is the matrix in the deep, because there is the good feature of the matrix in the BGP. So I'll explain that part very well, but right now you just understand it is matrix, only one matrix. So the matrix between these two router is the 10, and the matrix between these two router are 20. So what is that? What is called the routing update packet? So it will just put the mask in the IP, network IP, and the mask, yeah, and the via R1, yeah, and it will put the matrix. So matrix is the 10, yeah. So that update packet, it is sent from the R1 to R2, and once it will receive by the R2 just forward that update packet to the R3. Yeah, same update packet it will forward. Yeah, it will forward, but it will change the matrix. Yeah, it will change the matrix, like here is the 10 and here is the 10. So 10 plus 20, it is sent the 30. It will send to 30 matrix. Yeah. So in that update packet, matrix will be changed. That's why it is called the routing update packet. Yeah. And here is the R4 router, suppose. And between here to here, matrix is suppose matrix is the 10. So in it will send the R3 to R4, that update packet. So it will update the matrix. 30 plus 10, 40. Yeah. So it will send the matrix 40. So hope by hope, its matrix is changed. Yeah, between this router to this router, matrix is same, and between this to this, it's a 30, and between R3 to R4, its matrix is the 40. So hope by hope, matrix is changing. That's why it is called the routing update packet. Yeah. But what about the OSPF and ISIS? OSPF and ISIS not send the routing update packet. They are sending the link state advertisement. They are sending the LSAs. So in LSA, link state advertisement, the matrix from here to here is sent, and it is sent to here 10, and it is sent to R3, sent to R4, only 10. So now, hope by hope, the matrix is the same. Yeah, matrix is not changing hope by hope. So that is called the link state advertisement. But here is the matrix is changing hope by hope. That's why it is called the routing update packet. So BGP sends routing update packet non-periodically. What do you mean by non-periodically? Non-periodically, it means Suppose this loop back up, yeah, it is down after 4 years. 4 years. Yeah. After 4 years, it goes down. Yeah. After that update packet advertised to here to here. Yeah. Suppose my neighbor, I'm the bachelor. Yeah. Sorry, I'm a married person and my neighbor is also married. Yeah. They are couple and I'm also living with my family. So we are not going to moving, means not periodically going from one house to other house. Means my neighbor is not coming periodically to my house and I'm not going to periodically to my neighbor house. They on that time, whenever any functions are there in our house, then we invite our neighbor. Yeah. We are not going to periodically. Yeah. Non-periodically means whenever any change, then we go to the neighbor house or neighbor come to my house. Like my child birthday is there, like my marriage party is there. Yeah, yeah, anything means whatever the party, we invite our neighbor. So same here. If suppose this loop back up for 4 years and it will goes down, it is goes down. After that, it will advertise that update packet to R2. Till the 4 year, it will not advertise that update packet from R1 to R2. Yeah. So from R1 to R2, whenever any change, like it never, like this loopback goes down or this loopback goes up, on that condition, it will advertise the update packet to the neighbor. Until and unless it is not advertised the update packet to neighbor. So that is called the non-periodic. So BGP sends routing update packet non-periodically. And to BGP speakers, it will send only BGP speakers. What do you mean by BGP speakers? Suppose I am configuring the BGP in this router and I am configure BGP in this router. I am not configure BGP in this router. So it will advertise that update packet to not this neighbor. It will directly advertise that update packet to R3. It is not advertised to R2. Yeah. You thought that in between R1 and R3, R2 is there. So how it is possible? It is coming via R2. Yes, it is coming via R2, but the update packet is encrypted. Means R2 see that update packet, but R2 cannot understand the BGP update packet because BGP is not running here. So it acts as a real data. Yeah. So BGP update from R1 to R2, yeah, via R1 to R3 via R2, but R2 act as a real data. So R1 means the BGP sends a routing update packet non-periodically to BGP speakers by unicasting. The one of the most feature in the BGP, that is the unicast feature. That feature is only in the BGP, yeah, not in other routing protocol. OSPF, EIGRP, ISIS, each and every protocol is the multicast protocol, but BGP is the unicast routing protocol. What do you mean by unicast? Unicast means it is sent one to one. Yeah, it is not doing the broadcasting. Like in the OSPF, suppose this R1 router, this is the R2, this is the R3, this is the R4. Yeah, this is R2, this is R1. All are connected. Suppose I'm running the OSPF. So OSPF send update packet. Suppose here is the loopback one. So from R1 to R2, it is sent OSPF send this neighbor. OSPF send also routing update packet to this neighbor. OSPF send routing update packet to this router. Means OSPF send update packet and EIGRP is also send update packet to each and every routing protocol. Yeah. But BGP is the good feature. It is the unicast feature. Suppose I'm running the BGP here. 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 And I want to advertise this update packet. Suppose this is the Geo. Suppose this is the Tata. And suppose this is the RFOM. There are three ISPs are there. and I want to advertise this update packet only to the Geo. Yeah, I'm not advertise that update packet. I don't want to advertise that update packet to Tata and Airtel, Tata and Arcom. So my update packet only advertised to the Reliance Jio. It is not advertised to other neighbors. That is the one of the good feature. That is called the unicasting. Means whatever you want to send to that neighbor, it will send to that neighbor only. Like if suppose I want to give some sweets to my neighbor, and suppose I send my child to give the sweets to my neighbor. So I'm sending my child to neighbor house. So they are sending the sweets. Their responsibility to deliver the sweets, but they can share the other information, whatever in their school, whatever in their house, whatever information asked by the neighbor, they can ask, because child don't know what information I would need to give on the neighbor and what information I do not need to give on. That concept is not in the child. They can, he's like a multicast. He share all the information to the neighbor. Yeah, you don't worry about the what information I need to pass. I need to only pass the switch, but he's given everything. So like OSPF is the like a child, EIGRP is the like a child. They are doing the multicasting. Multicasting means all information passed to the neighbor. Those information not shared by the OSPF to neighbor, that information also passed by the OSPF to the neighbor. But in the BGP, it is like adult. Adult means suppose me or my wife or my some father, mother, anyone given that sweets to neighbor. So we just given the sweets and after that we come back. We are not sharing other information because we know we are coming for the given the sweets. So we only share the sweets. So adult are the BGP, whatever information they want to share, only that information shared to that neighbor only. So similar like that, it is the unicast neighbor. Unicast means it is sent to Geo. It do not want to send the Tata and the Alpha. So that update packet only shared to Geo, not other information shared by the BGP. So that is called the unicast. So the BGP definition, BGP sends routing update packet non-periodically to BGP speakers by unicasting. All 4 points are clear. So that is the definition of the BGP. Yeah. So in the general interviewer asked why we use BGP. So the first advantage of the BGP, its feature is the unicast feature. That is the first feature. And the second feature is that it is create the indirect neighborship. That is the also the other advantage of the BGP. So let me explain. It is create the indirect neighborship. So let me explain that part. This is the R1. This is the R2. This is the R3. So there are three neighbors are here. Yeah. So So in the OSPF and the EIGRP, in any multicast routing protocol, the problem is that they can only create the direct neighborship. They cannot create the indirect neighborship in the OSPF and the EIGRP. The problem is that they can they can only create the direct neighborship because they are exchanging the hello message. Yeah? In the hello message, network ID is going. Yeah. Suppose this IP address is 12.0.0/8.2.1. This is the 23 R2 and R3. So 23.0.0.0/8.2.3. Let me explain. I'm teaching you the BGP. So in the entire BGP, I'm just using the simple IP address. Like what kind of simple IP address? Suppose this is the R1 router and this is the R2 router. So I will pick up the 1 and I will pick up the 2. So that's a 12.0.0.0. So they said this is the network ID and the first IP address .1 to R1 and .2 to R2. Yeah. Similar like that here, R2 and R3. So 23.0.0. Its IP address is it is the R2. So 2, it's R3. So .3. So 23.0.0.2 and 23.0.0.3. So I'm taking the simple IP address in the BGP, entire BGP. Whatever I'm performing the lab or anywhere, I will use the simple IP address. So come back to our topic. BGP create the indirect neighborship. So OSPF and EIGRP or ISIS, they are not able to create the indirect neighborship because they are sending the hello message. In the hello message, they are they are putting the network IP. Yeah. Suppose in between these two router, so network IP is this one. Suppose this update packet sent to R3. So R3 network IP is 23 and its a network IP is the 12. So R1 and R3 cannot become the neighbor because their network IP are different. That is the problem. They cannot create the neighbors. Yeah, because network IP is the different. But BGP, BGP send the not hello message. I'll explain you about the in the next lecture, in tomorrow lecture. I will explain about the I will explain about the open message. In the open message, network IP is not going. Network IP it is not sending. Open message similar like the hello message, but there is the difference. I'll explain you in the next lecture in the tomorrow. But right now, this is the R1 and R3. They are sending the they R1 and R3. They are creating the neighborship because in the open message, in the hello message, they are not sending the network IP. So here R1 and R3 can become the neighbors. Yeah. So BGP second advantage is that it can create the indirect neighborship. Yeah, that is the best feature. In MPBGP, there is the feature that's in MPBGP they can create the indirect neighborship. That is the also advantage of the MPBGP. So in MPLS, we will start the soon batch, MPLS batch. So in MPLS, I will explain you they can create the indirect neighborship. Yeah. So they can create the indirect neighborship BGP. It is the second advantage of the BGP. Yeah. And BGP is the non-periodic protocol. What we mean by non-periodic? Non-periodic means whenever any changes, then they will acknowledge. And it's the hello message is also non-periodic. So whenever any protocol is non-periodic, so they are using there are in the transport layer, there are two protocols. One is the TCP, other one is the UDP. TCP always given the acknowledgement, but UDP is not given the acknowledgement. Yeah, UDP is not given the no acknowledgement. Yeah, so BGP require the acknowledgement because BGP require the acknowledgement because it is a non-periodic protocol. So that's why BGP use the TCP protocol. Yeah, for the acknowledgement. So BGP use the TCP protocol whenever any update packet is delivered, it will acknowledge. Like in the credit card, there are two types of service provided by the bank. Whenever we order any credit card, whenever we apply for any credit card, so whenever the bank deliver the credit card via courier, so courier person come in my house, they can take my signature and after that he will deliver the credit card to me and that signature he will he will show the in the bank I have delivered your credit card. You can see the signature of the customer. So it is an acknowledgement. Yeah. So because credit card come in one time, it is not credit card not come every month. Yeah. It is delivered in the one time. So whatever delivery is the one time, we need a acknowledgement. But after that, the statement coming every month. Statement come every month. So in that case, the bank, whenever anybody deliver to bill, credit card bill, so they are just keep in our society box. Yeah, whatever you are living in the society or you are living in your house, so you just put the box. In that box they can put, and they cannot take the signature, they cannot inform you. Just put in the in front of gate or in front of the box. Yeah, they are not given any kind of acknowledgement because bill is coming in every month. Yeah, bill is the periodic. So that's why credit card bill we cannot given the acknowledgement. So same here is the credit card. So TCP require the acknowledgement because TCP given the acknowledgement because it is a non-periodic. So whatever any kind of non-periodic service, yeah, non-periodic service, periodic service, we need a acknowledgement. Yeah. So BGP requires the acknowledgement. So that's why BGP use the TCP protocol for the acknowledgement. So BGP interviewer also asked BGP work on which layer? Yeah, that question also asked by the interviewer. Yeah. So BGP work at layer 7. There are the 7 layers. Here is the 7 layers. This is the application layer. Application layer. Here is the presentation layer. Here is the station layer. Yeah. Here is the transport layer. Here is the network layer. And here is the data link layer. And this one is the physical layer. So there are total 7 layers. This is the layer 1, this is layer 2, this is layer 3, this is layer 4, layer 5, layer 6, layer 7. So BGP use the service of the TCP. So BGP we cannot keep on the layer 3 because if I'm putting the BGP at layer 3, so my OSI concept will be failed. Because OSI concept, what OSI concept tell us? Lower layer always provide these services to the upper layer. Lower layer always provide the services to the upper layer. Yeah. Suppose in my company boss in the like my company owner in the upper layer. So I am providing the service to my company. I'm given the network service means to up their network. So I'm providing the service to my company owner. So I'm providing the service to my company. So this is my company and this is me. So lower layer provide the services to the upper layer. So always lower layer provide the services to upper layer. So similar like that, this is the layer 4. Yeah, this is the layer 4 and TCP work at layer 4. If I'm putting the TCP in the network layer, so my OSI concept will be failed because upper layer cannot provide the services to the lower layer. So BGP, I can put not in the network layer. But if you think about that, suppose you thought that BGP put in the session layer. So BGP actually, we all the protocol work at network layer or application layer. Why they are working on the network layer and application layer? Why they are not working presentation session, data link physical? Because the problem is that these two layers creating the packets. Yeah, BGP also create the packets. So BGP create the packets. So I cannot put packet creation not performed by session and presentation layer because session layer work to provide the sessions. Presentation layer to work provide the layout template. Yeah. So this two layer not create the packet. Yeah. So I need to put the my BGP in layer 3 or layer 7, but layer 3 I cannot put because OSI model will be failed. So that's why I put the BGP at layer 7. Yeah. BGP put at layer 7. So BGP work at the layer 7, BGP not work at layer 3. Yeah. So BGP work at layer 7. Yeah. So BGP work at the layer 7. And any protocol, yeah, suppose in the our company, we identify via, whenever we identify via the our employer ID, our salary come using only for the our employer ID because company don't know our name. Company knows only our employer ID. So similar like that in the network, like router, switches, not switches, router, PC, they only know the, no, they don't know the BGP. They know the protocol number. Yeah. What is the protocol number? Let me explain. Because without protocol number, network not identify the protocol, network not identify the application. Yeah. So PC or router, both are know the protocol number and both are know the port number. So what is the port number? Without port number, router cannot understand the BGP. Router cannot understand the OSPF. Yeah. So they knows only using the port number or protocol number. So let me explain about the port number. It is like an employer ID. Yeah. So let me explain the port number. So BGP work at layer 7. Yeah. And when once it will come in layer 4. So BGP update packet is here. Yeah. They are using the TCP port number. Yeah. Because without port number, it cannot identify the means router cannot identify the BGP update packet. Yeah. Router don't know the BGP. Router know the it's a port number. It's a port number 179. Yeah. So BGP knows only port number. Sorry, router knows only port number. So what is the port number? Let me explain. Suppose this is the source and these are the destination. These are the destination. Suppose this is the Gmail. This is the Facebook. And suppose this is the, some other website like, let me take router. This is the router. So there are three, destination and route PC is the single. Yeah. So they all are accessing the Gmail, Facebook, source accessing the Gmail, Facebook, and the router. So suppose Gmail port number is 443, Facebook port number is 80, and we use the SSH, so it's port number 22. These are the destination port. Yeah. And source, source for Gmail, it is use the Gmail application. Suppose Gmail application look like this. Yeah. It is in my mobile, suppose. This is the application. Yeah. App. This is the Gmail. Yeah. And for Gmail, it is use the local port and the destination port. Destination port. So destination is the 443. So destination port is 443. Yeah. And local port, it is use the like any local port. Yeah. Like any shopkeeper sell their shirt. So the original price of the shirt is the like 500 rupees and 500 rupees. And if a shopkeeper sell that shirt in only 500 rupees, so shopkeeper cannot survive. So that's why shopkeeper put the any kind of take in the original price. Yeah. And that take is like not 500 rupees. That take is like XYZ. Yeah. XYZ means 600 rupees. Yeah. ABC means 800 rupees. So whatever their requirement, like they want to take a margin of 100 rupees, so they can put the take XYZ. So that XYZ only know by the shopkeeper and their employers. No other person cannot understand that XYZ. Yeah. So that is called the local take. Yeah. Similar like that, here it is used the local port, suppose 111. Yeah. 11. So it is send the message and the source port is 111. Yeah. 111. And destination port is 443. Yeah. That update packet sent to the Gmail. Yeah. Similar like that, this is the Facebook, suppose. Yeah. This is my Facebook. And its port number is the 80. Yeah. Its port number is 80 and it is used the port number 222. 222. Yeah. So it is create the one kind of update packet. Here it is mentioned the port number 222 and the destination port number is the 80 and it is sent that packet to the Facebook. Yeah. And similar like that, suppose this is the router. So I use the putty, and suppose putty I will use and putty port number is 22 and local port suppose it is used 333. Yeah. So it is create the, it is generate the packet, source and the destination. So destination port is 222 and the source port number is 333. And then update packet sent to the router. Yeah. After that, you know, the router, everyone given the reply, everyone generate the reply packet. So they are generate the reply packet. This is my reply packet. Yeah. Here is the source. Here is the destination. So this port is like a reverse. Yeah. The source port will become the destination port and destination port will become the source port. And after that, that packet, reply packet sent to the PC and destination port is 111. So that traffic go to the Gmail only. Yeah. If I am not putting the source port number, if I am not using the port number, so my application cannot identify. Yeah. So why we need port number? To identify the protocol, identify the port number application. Yeah. So here is the packet is going. Port number is 111. It is directly go to the Gmail. Yeah. It is directly go to the Gmail. So it is identify the Gmail application. So why we need port number? To identify the application. Yeah. After that, it is Facebook is also generate the reply packet. It is also generate the reply packet, source port and the destination port. Yeah. Source port is like 80, it just reverse. And destination port is 222. That packet sent to the source and the destination port is 222. So it is sent to the Facebook only. Yeah. So why we use port number? To identify the application. Yeah. Without identify the application means why we need port number? To identify the application. Yeah. Similar like here, the router is also create the reply packet. And in the reply packet, source port and the destination port, source port is 22 and destination port is 333. Just they are reverse port number. And it is sent to the source. Yeah. Once it is reached to my PC, it's a destination port is 333. So that packet goes to the putty only. Putty only. Yeah. So that port go to putty. So here is the, why we need port number? To identify the application. These are the application. So why we need port number? To identify the application. So similar like that, my BGP work at layer 7. Yeah. So at layer 4, it is use the port number. Yeah. It is use the port number. So BGP port number is 179. 179. Here is the transport layer. In transport layer, TCP's work. Yeah. So its port number is 179. So BGP use port number 179. Yeah. And you also heard about the protocol number. So those protocol working like OSPF and uh, the EIGRP. Yeah. Because they are working at layer 3, so they don't have port number. Because those protocol work in application layer, they have the port number in layer 4. Yeah? They have the port number in layer 4, but those protocol are working at layer 3. They don't have the port number. They have the protocol number. Yeah. How router identify OSPF and EIGRP update packet? Using the protocol number. Using the protocol number. So those protocol work at layer 3. They have the protocol number. Those protocol work at the layer 7. They have the port number. Like one of the protocol REAP, it is outdated. So REAP work at layer 7. So they have the protocol number. Sorry, port number. Like HTTP work at layer 7. So they have port number 80. HTTPS, it is work at layer 7. It's your port number 443 at layer 4. Yeah. So those protocol work at layer 7, they have the port number, and those protocol work at layer 3, they have the protocol number. Yeah. So BGP work at layer 7, it having the port number 179. Yeah. So BGP work at layer 7. Yeah. In the like a CCI exam, if you are given the exam, so there is the you should see the carefully options like BGP work at layer 7. Yeah, BGP work at layer 7. BGP kept in layer 7, but BGP work for layer 3. That is the very tricky. BGP BGP work for layer 3. For layer 3. Like suppose in the Mumbai, here are Mumbai, NCR is the Navi Mumbai. So most of the people, those are IT guys, they are living in Navi Mumbai and they are going for the job in the Mumbai. So those are the IT people. They're living in Navi Mumbai and they go for the job in Mumbai. So I'm living in Navi Mumbai. I work at Navi Mumbai. Means I'm living in the Navi Mumbai, but I work for the Mumbai. Yeah. Similar like in Delhi, like Noida and Gurgaon, most of the companies in Noida and Gurgaon. So most of the people living in Delhi. So they says that I'm living in Delhi, but I'm going job. I'm working for the Gurgaon and the Noida. Yeah. So similar like that, BGP work at layer 7. It is kept at layer 7, but it is work for the layer 3. So BGP work for the layer 3. Yeah. So BGP work for the layer 3. Yeah. So BGP work at layer 3. So you can write down BGP work at layer, BGP work at layer 7, but BGP work for layer 3 because BGP work for the routers and routers kept at layer 3. So it is you know it is work for routers. Yeah, but it is create update packet in layer 7. Yeah, so it is work at the layer 7, but work for layer 3. That is the main difference, 8 and 4. So this is the other way, BGP border gateway protocol. Yeah, and suppose in the BGP, which one is the fast? Yeah. So the this is the OSI model. Which one is the fastest? Suppose EIGRP and the OSPF work at layer 3. Yeah. OSPF work at layer 3. EIGRP work at layer 3. Yeah. BGP work at application layer. In the OSI model, BGP work at application layer. Yeah, this is the layer 7. So, who will be fast? BGP is fast or OSPF or EIGRP will fast? Who will be fast? So if suppose somebody living in their in building means in the building number 7, yeah, floor number 7, and somebody living in the floor number 3. So if somebody want to come in road, so who will come fast? Building number means floor number 3 come very fast, and floor number 7 come very late, because it is crossed the 6 floors, and after that it will come down. Yeah, but building number floor number 3, it will come very fast because it will cross only two floors. Yeah? So similar like that, who will be fast? BGP will fast or OSPF EIGRP will fast? So OSPF and EIGRP will be fast because they are work at layer 3. But BGP work at layer 7, it is very slow. Yeah? So BGP is very slow protocol, and I'll explain you why BGP is a slow. Yeah? Because BGP work between the layers, and between layers link are limited, bandwidth are limited. So we cannot share the much update packet on the link. So BGP is very slow. I'll explain in the deep, but right now you can just understand BGP is the slow protocol as compared to OSPF and the EIGR. Yeah, and this is the BGP. BGP work at this is the application there. BGP work at application there, and this is the presentation. This is my station, and this is the transport. Transport TCP's work. After that, layer 2 data link, and layer 1 physical. So BGP work at layer 7, and it is it is very slow protocol. Everyone knows. So BGP BGP require if anybody living in layer building floor number 7, so they need floor number 1, 2, 3, all the floors will up, then building number 7 will be up. Similar like that, you know, if if you want to make the BGP up, suppose these are the two routers. This is the R1 router, and it is R2 router. Yeah, R2 router. This is the IP address. So if you want to create the neighborship between R1 and R2, between an R1 and R2, you want to create the neighborship. So you should up the layer 1 up. What do you mean by layer 1 up? If suppose this physical link goes down, so BGP will never up. Yeah. So BGP first requirement is that the layer 1 should be up. Layer 1 should be up. And the second requirement is that layer 2 should be up. Suppose, here is the PPPR, SDLCR, Ethernet is running. So if suppose Ethernet, so MAC address are here. So this router should know the MAC address of this router. This router should know the MAC address of this router. Yeah. If they don't know the MAC address to each other, point-to-point MAC address, they don't know. So BGP will never up. Yeah? So layer 2 should be up. Yeah? And after that, layer 3 should be up. What do you mean by layer 3? Means this IP address should be assigned, and R2 router should ping the R1 router. If routing is not here, so they cannot ping. In my case, it is a directly connected, so routing is not needed. Only you assign the IP address, they are directly pinged. But I will teach you about the loopback IP address. Suppose this is the loopback, and this is the loopback, and I want to ping the loopback from this router to this router and this router to this router. So without routing, they cannot ping. So I need to run the static route, EIGRP, OSPF, any protocol. After that, they can ping. and then OSPF EIGRP static route you are running here, and over here you can run the BGP, because BGP always up once the layer 3 is up. If this router are not ping, this loopback IP address is not able to ping, so your BGP never come up. So the second requirement is that layer 3 should be up. Means routing should be ready. Yeah. And once routing is ready, so in the layer 4, TCP is running. Layer 4 TCP is running. So TCP should also up. If TCP is not up, so BGP will never up. So all the 4 layer will up, then at layer 7, BGP will up. Yeah. All 4 layer up, then BGP will up. So first TCP session will be up. Means all 4 layers should be up. So TCP cleared their sessions. Yeah. TCP cleared their session. And over the TCP, BGP will run. Over the TCP, BGP will run. Yeah. BGP will run. So over the TCP, BGP will run. Yeah. So all 4 layer will up. Means TCP session will up. Then BGP will up. Yeah. Like in the lane, if lane is not ready, so we cannot make the flyover. Yeah. If lane is ready, so I can make the flyover. Yeah. So similar like that, if TCP is up, then BGP automatically will come up. Yeah. So we in the during the uh, classes, I will explain you if TCP goes down, then BGP will down. So I'll explain you that part later on. But right now, BGP required layer 1 should be up, layer 2 should be up, layer 3 should be up, layer 4 should be up. All 4 layer will up, then BGP will come up. Yeah, then BGP will come up. So that is the BGP requirement. Yeah? So this is also one of the these things we should know. And let me explain the different ways. I'll cover the basics of the BGP. In the next lecture, I will teach you about the OSPF states. So this is my router. Suppose these are the routers. This all 3 router managed by suppose Airtel, Airtel, Airtel. Yeah, Airtel managed by Airtel, and this 2 router managed by Geo, Geo. Yeah. So this 2 router managed by Geo, and Airtel and Geo are connected together. They are connected together. So how can identify this in the internet? How we can identify this is the Geo, this is the Airtel? Like whenever somebody call me from out of India, so how I can identify in which country he called me? So I can check the port number. Yeah. If suppose he's calling from Singapore, so it is use the telephone in the telephone port number 93. Yeah. If somebody called from US, so it's a first digit port number is +1. Yeah. Europe, like a UK, +44. Yeah. So anybody call from means every country have their own port number, own telephone directory code number. So similar like that, this ISP Geo, how I can identify this is the Geo. Yeah. So in internet, they are use the AS number. What is the full form of AS number? What is the full form of AS number? It's a autonomous, auto no, autonomous, system. Autonomous system. Full form of AS, autonomous system. So every ISP or every enterprise or every any kind of network which is identified using the AS number. So its AS number is 100. Its AS number is the 200. Yeah. So what is the AS number? Like in the word, God is not created like a country boundary. Yeah, a country boundary. We just according to our people selection, people of group, they are created a country. Yeah. So similar like that. This is the internet. Suppose so in internet, these are the this is the Airtel, this is the Geo, and this is the other ISP Tata. So how we can identify? So using the AS number. So AS number is the logical boundary. Logical boundary. So what is the AS number? It is a logical boundary which is managed by single administration. Single. What do you mean by the single administration? Administration means it is managed by Airtel persons, Airtel engineers, Airtel organizations. Yeah. So Airtel organization, all team will manage this AS. Yeah. So what is the AS number? It is a logical boundary of the router, which is managed by single entity or single organization or single administration. Yeah. So this router managed by the Airtel, this router managed by the Geo. So this is called the AS number. Yeah. So here is the AS number Geo, and this is the AS number 200 is the Airtel. If I am running the BGP between this is the R1, this is the R2, this is the R3. I'm running the BGP between R2 to R3. I'm running the BGP between R1 to R2. Yeah. So this BGP, it is running within the AS. So this BGP is called the IBGP. What do you mean by IBGP? IBGP means interior BGP. Interior BGP. Interior BGP means this this BGP running within the AS. If BGP run within the AS, so that is called the IBGP. Yeah, within AS. Within AS. Or I can say inside of the AS. If any BGP run inside of the AS, that is called the IBGP. Yeah. This suppose these are also running the BGP, so that BGP is called the IBGP. Yeah. So if any BGP running within the AS, so that is called the IBGP. If any BGP running between the AS, yeah, between the AS, so that BGP is called the eBGP. eBGP. eBGP full form is the eBGP. Exterior. Exterior. Exterior BGP. Yeah. Exterior means between the AS. Between the AS. AS. Yeah. So if BGP is the running between the two AS, so that is called the eBGP. If BGP running within the AS, so that is called the IBGP. So BGP are the two type, eBGP and the IBGP. So there are two types of BGP. Yeah. So in next lecture, that things is also very important. What is the IBGP and eBGP? Yeah. And I will also explain why BGP name is different I and E. Yeah. So I'll explain later on classes. Yeah. But right now this BGP is I and E. Yeah. So there are two types of BGP, IBGP and eBGP. I'll explain you open message in the next class. On that class, IBGP and eBGP is very important. But right now I'm stopping the class. In the tomorrow, I will explain you other things. Yeah, like open message and BGP.